Hey, there's a graph here. We got a couple of do now questions. So for the red line, which has been graphed, there is an x-intercept indicated um, and a y-intercept, which has been indicated there. Which coordinate is the zero? Right. So each of those 2 points have two coordinates, an x coordinate and a y coordinate. I've highlighted those with the green and the blue spaces. So which of those two spaces is going to get a zero for the x-intercept? And then over here, which of those two coordinates is going to get a zero for the y-intercept? Come up with an answer, hit pause till you're done. All right, well, welcome back. So for the x-intercept, those coordinates would be -4, 0, which means the 0 is going to be the blue or the y coordinate. And for the y-intercept, the coordinates of that point would be 0, 3, which means the 0 is going to be the green one. That's the x coordinate. So there's a lot of vocabulary words. You got x-axis, y-axis, x-intercept, y-intercept, x-coordinate, y-coordinate. There's a lot of different words. They're all sounding very similar. They start with an x, they start with a y. All these different words, like an x version, and they all have a y version. So we have to pay attention to all of the details and not just go by sound, because sometimes if we just go with the first thing we hear, and you hear like x, and you assume it's going to be the x whatever. You think, oh, it'll be the x coordinate, but we're actually talking about the axis or whatever. So we got to pay attention. I'll try to slow down and point out what words actually we're using. The words we're using today are intercepts. So we're going to look at the x-intercept and the y-intercept and use those as a method to create a graph. So that is our learning target. You'll be able to find the x-intercept, you'll be able to find the y-intercept, and use them, those two separate points, to make a graph. So some recap. We looked at graphing earlier, and a method that we have seen to make a graph is to create a table. So if we're given an equation like y equals -x plus 5, we can create a table of values. We can choose whatever x numbers we want. In this case, I chose the x numbers, and then use that equation to calculate the y coordinates for each of those different x values, right? So it took a lot of work. Scroll through there. So we completed this whole entire table. Once we had the table completed, each pair of numbers, the x that we chose and the y that we got from the equation, go together to create one point on the graph. So this is the 0, 5 is the red point right here, and then 1, 4 is that blue point right here, and so on. Well, after that, we learned about some properties of intercepts. The x-intercept will always have a y coordinate of 0, like we just saw in the do now. So the coordinates are going to be x, will represent some number. For every different graph, every different equation, you have a different number for the x-intercept. But the second coordinate, the y coordinate, will always be a 0. That is what makes it an x-intercept. And for the y-intercept, similar but opposite. The x coordinate will always be 0. So that's the first number in those set of coordinates. It's always going to be 0. And then the second number is going to be some number y. If we had the equation of the graph, we could figure out what number that is. It'll be a different number for every graph or every equation. But something. We'll go there in the y spot. So every single x-intercept has 0 in the second spot. Every single y coordinate over here in pink is going to have 0 in the first spot. That's what we had seen beforehand. And so that is the thing we use to find the intercepts. So here's what that's going to look like. We're going to make a graph of this equation, 2x minus 4y equals 12. And rather than making a table of values and populating that whole table full of numbers and then using those to create points on the graph, we're only going to identify these 2 points, just the x-intercept and the y-intercept. And we'll use those 2 points to create the graph. So the reason why we use x-intercepts and y-intercepts is actually because they're easiest to find. To find the x-intercept, I'm going to copy that equation down and change the y part of the equation to 0, because that's the thing that defines an x-intercept. It's going to have an x number, but the y is going to have to be 0. So I changed the y to 0 so that I can find the x-intercept, solve the rest of the equation. And in this case, I came up with x equals 6, which means the x-intercept would have coordinates 6, 0. So I want to make sure I get those as coordinates and not just leave it as x equals 6. It's too easy to get confused if we just leave it as oh, it equals 6. And I don't actually know where that is on the graph. Then to find the y-intercept, I copied that equation down again, and this time I changed the x part of the equation to a 0 because that is what defines the y-intercept. It's going to have a y, but it is not going to have any x value. The x is going to be 0, so I changed that to 0. Make sure this negative sign comes down to the next line, so 0 minus 4y, and then negative 4y equals 12 is my next version of the equation there. So when I solve it for y, I'm going to end up at y equals negative 3, which means the coordinates for the y-intercept are going to be 0, negative 3. So my two intercepts for the x-intercept is 6, 0, and the y-intercept 0, negative 3. So I want to copy this work and bring it with me to a graph. So here's that exact same equation. I'm just going to copy my previous work so I know what the coordinates are. And now I want to put these 2 points on the graph. So do not combine the 6 from the x-intercept and that negative 3 from the y-intercept. Sometimes people try to put those together and come up with this combined coordinate of like 6, negative 3 or something like that. We don't want to do that. These are 2 separate points. So 6, 0, I'm going to go across on the x-axis, go sideways, go across to positive 6. And I don't go up anywhere because the y-coordinate is 0. The blue one is the y-intercept is going to be on the y-axis. So the first coordinate 0 means I don't go left or right, but then negative 3 means I need to go down to negative 3. Once I have these 2 points drawn on the graph, now I'm going to connect them with a straight line. I'm going to try to get my line to actually go through the points. And there we go. Now I'm going to put arrows on both ends of this line because this does represent an infinite line. There are an unlimited number of points. I've only used 2 to make my graph, but the line does represent an infinite number of points. So we could create an infinitely large table of values if we were so inclined. Of course, we're not. We're just going to use these 2 points. But arrowheads go on there. And just change this to red so that we can see the difference between the line we graphed and the background. Okay, let's do another example just to make sure we got this under control here. So we're going to graph this equation 6x minus 9y equals negative 18. So my first job was to find the x-intercept, to copy that equation down, change the y to 0, solve for x. I got negative 3. So my x-intercept will be at negative 3, 0. And then similar process to find the y-intercept, copy that equation down, and this time I changed the x into a 0, solved for y, and I ended up at y equals 2. So my y-intercept will be 0, 2. So again, I'm going to copy this work so that I can put it onto my graph. There's that same equation, 6x minus 9y equals negative 2. So here are my 2 intercepts, and I'm going to graph points now. So at negative 3 is 0, that's my x-intercept. So I'm just going to move to the left to find negative 3. And then the y-intercept is at 0, 2. So that's going to be up on the y-axis at positive 2. Connect those 2 dots with a straight line. So I do want the line to go past the dots. It's not just connect this dot to that dot. WAMAP's going to draw a line for you that will be off, to the edge, both edges of the graph. But I want to make sure that I am representing this line goes past the dots. It goes forever in both directions.